Okay, hello everyone. See the question number 17 in Stoichiometry worksheet 4. Okay, see the question. So it is given the hydrated Na2SO4 XH2O. So it is given a hydrated, but the X value is not given. Though it undergoes a 56% loss in weight on heating and become anhydrous. Anhydrous becomes means it loses total water molecules. We have to find what is the value of X. Means what is the reaction? Reaction means just losing of water molecules. Na2SO4 XH2O. On heating, what happened? It becomes anhydrous. Anhydrous means it does not contain any water molecules, so it becomes Na2SO4 plus XH2. We have to find all this XH2O. So here important, we have to find what is the X value. So how to find the X value? What is the clue is given means it undergoes after losing water molecules, it undergoes 56% loss in weight. Means what is the weight of H2O molecules? That is equal to 56%. ఓకే అంటే మనం ఎన్ని నెంబర్ ఆఫ్ మాలిక్యూల్స్ ఎంత వెయిట్ ఆఫ్ తీసుకుంటే దట్ విల్ బి ఈక్వల్ టు ద 56% ఇంటూ టోటల్. అంటే టోటల్ మాస్లో మనం 56% రిమూవ్ చేయాలి. ఓకే, సో యాక్చువల్గా ఈ ప్రాబ్లం డైరెక్ట్ చేయడం కంటే విత్ ద హెల్ప్ ఆఫ్ క్లూస్ వీ హ్యావ్ టు ఫైండ్. సో దిస్ XH2 is what? 56%. 56% లాస్ అయింది. So loss is 56%. Loss is 56% అంటే how much compound is formed? So Na2SO4 and XH2O, that is equal to 56%. And the total weight lo manam 56% value find out cheyali. Okay, so first we see what is the Na2SO4 weight. What is the Na2SO4 molecular weight? Because we don't know about the X value. Na2SO4, that is a 46, 32, 64. Okay, 12 here we get 142. So 142 is a common Na2SO4 XH2. For example, ఇక్కడ X equal to take the first option. So మనం ఫస్ట్ ఆప్షన్ తీసుకుంటే 5 H2Os అవుతాయి. ఆ 5 H2Os తీసుకుంటే what is the total mass? ఆ 5 H2Os mass total massలో it should be 56%. ఓకే, సో అట్లా ఆప్షన్ వైజ్గా మనం క్యాలిక్యులేట్ చేయాలి. సో డైరెక్ట్గా క్యాలిక్యులేట్ చేయడానికి there is no other method. Direct calculation is not possible for it. Okay, for example, just take the option A. So according to option A, that is Na2SO4 5H2O. What is its total weight? Na2SO4 142, 1 H2O molecule, that means 18. Here 18, 5, 90. So here we get 142, so 232. Okay, the total mass is 232. So 90 is water molecule. Is 90 is equal to 56%. ఇప్పుడు వాటర్ మాస్ 5H2O తీసుకుంటే 90 grams. 90 grams వాటర్ మాలిక్యూల్ తీసుకుంటే వాట్ ఇస్ ద టోటల్ మాస్? 232. అంటే ఇప్పుడు ఈ వాటర్ మాస్ అనేది దీంట్లో 56% ఈక్వల్ అవుతాయి. ఇట్ విల్ బి ద కరెక్ట్ ఆప్షన్. సో the percentage of H2O equal to 90 grams by total into 100. So here we are getting approximately, okay, just wait and we'll see the calculation. Okay, all calculation we do one time. Next, I'll check the option B. So here Na2SO4 3 H2Os. We have to consider the third option. Then how much we will get? The 142. So 18. That is equal to 196. Therefore, what is the percentage of H2O equals? 54 grams by 196 100. Let's check the option 3. Option 3, how much is given? 7 was given. So option 3, Na2SO4. If you take the second or third option as a correct, how much we get? 142. 7H2. 7H2 means 7 into 18. Here we get 126. That is 268. So therefore here also percentage of H2O equal to 126 by 268 into 100. Next take the option D. So they are not appearing like 56%, but whatever it is, we do the calculations of all the options. So 142, this is 180. So total we will get 322. So here percentage of H2 is equal to 180 by 322 into 100. So we do the all calculations, just wait. So after the calculation, we got that if you take x equal 5 H2s, the hydrogen, the 5 H2 molecules weight is simply 38%. If you take the third, we should take the third option, second option, that is 3 H2s, we are getting only 27. If you take the 7 H2Os, 47%. If you take the 10 H2Os, then only it is exactly come 56%. Means what is the hydrated sodium sulfate means Na2SO4 10 H2O. Generally it is stable compound. Directly also we can guess the answer sometimes. Na2SO4 generally combines with the 10 H2Os. Okay, but this is the process for calculation. Means we have to go through with the options. There is no technique to calculate the direct x value. Okay, see the 18th question. Okay, see the question number 18. So it is given that 100 grams of ethylene. 100 grams of ethylene. Ethylene means it is C2H4. 100 grams of ethylene polymerized as like with the help like this reaction. I have to find the weight of formed polythene. So polythenes, these are generally known as polythene. We know generally it is used in the preparation of covers. Generally we use the polythene covers. Okay, that is a polymer. Polymer means it is formed generally the combination of many number of smaller molecules. Okay, so this is the polythene formation is best example for addition polymer. Addition polymers means మన starting లో ఎన్ని compounds తీసుకున్నామో the total compounds are added and combined a single compound. Okay, means here they took n number of ethenes, n number of ethene or ethylene same, and that n number are connected. For example, if you take 3 ethylenes or 1000 ethylenes, the 1000 ethylenes will be combined. How many carbons? 2 carbons, 2 carbons. Here 4 hydrogen, here 4 hydrogens. N number of molecules, n number of molecules. Means in this reaction we are not observing any loss in the number of molecules, nothing but any number of atoms. So starting లో ఎన్ని నెంబర్ ఆఫ్ ఆటమ్స్ ఉన్నాయో రియాక్టెంట్స్లో ప్రోడక్ట్లో కూడా సేమ్ నెంబర్ ఆఫ్ ఆటమ్స్ ఉన్నాయి. సో డిఫరెన్స్ ఏంటంటే రియాక్టెంట్లో అన్ని సపరేట్ ఉన్నాయి ఎన్ నెంబర్. సో ప్రోడక్ట్లో అవన్నీ దే కంబైన్డ్ యాజ్ ఎ సింగిల్ కాంపౌండ్. మీన్స్ దెర్ ఈస్ నో లాస్, there is no gain in the number of atoms. So therefore, so what will be the option? It's the same, 100 grams is the answer. So answer is 100 grams. So because reason you can write there is no gain, no loss in the product. The number of atoms in the reactants are equal to the number of atoms in the So polythene. Okay. So actually in any reaction, the number of atoms in the reactant products equal అవుతాయి. కానీ ఇక్కడ there is no subproduct. మనకు బై ప్రొడక్ట్స్ ఏం లేవు ఇక్కడ. సో టోటల్ ఫామ్ అయిన ప్రోడక్ట్ టోటల్ తీసుకున్న రియాక్టెంట్ మొత్తం ఒకటే ప్రోడక్ట్లో అంటే పాలిథీన్లో వచ్చేసింది కాబట్టి there is no weight, there is no loss in, there is no gain in weight. That's why the answer is exactly 100 grams. Okay, see the question number 19. So have to find the number of moles of CO2 required to convert 40 grams of caustic soda. What is meant by caustic soda? That is sodium hydroxide. To washing soda. Washing soda means generally the main product in it is sodium carbonate. Means we have to know the reaction of caustic soda with CO2 forming washing soda. So we are able to write the reaction. Caustic soda with CO2 forms the main product Na2CO3 and some water molecules. So to do this type of problems, it is compulsory to balance the equations. 2 hydrogens, I think it's already balanced. So the 4 oxygens, 1 carbon, 2 sodium. You have to comparison between sodium hydroxide and carbon dioxide. According to the problem, according to the equation, 2 moles of sodium hydroxide required 1 mole of carbon dioxide. It is given in terms of grams. CO2 already in terms of moles. Caustic soda in terms of grams. According to the problem, so sodium hydroxide means 2 into 40 grams. 2 into 40 grams of caustic soda required. How much? Required 1 mole of CO2. So very simple. Just if you know the reaction, it becomes very easy. Then what is the amount of carbon dioxide required for 40 grams? So 2 into 40 grams 1. So automatically 40 grams becomes 0.5. Okay. So it cancels, becomes so 0.5 moles of CO2 is required. Means here important thing is we have to know the reactions. Okay. Okay. See the question number 20. So how many moles of potassium chlorate, its name is potassium chlorate, should be decomposed completely to obtain 67.2 liters of oxygen at STP. So here also the writing of reaction is very important. So after writing the reactions becomes very easy. We know the decomposition of KClO3 reaction. So actually this reaction is useful in the manufacturing of oxygen. The manufacturing of oxygen is used with the help of this reaction. Okay, and it is also best example for irreversible reaction. So KCl with the potassium chloride on decomposition becomes potassium chloride and oxygen. So balance the equation. So 2 chlorines. Here we have to compare the number of moles of potassium chloride and the volume of oxygen. So first write the in terms of moles. 3 moles of potassium chloride on decomposition completely releases 2 moles of oxygen. Sorry, I think here it is 2. 2 moles of potassium chloride and decomposition gives 3 moles of oxygen. So we have to convert it in terms of liters. It is in terms of moles, no need to change. So it is 2 moles. I think already we got the answer. 3 moles means how many liters? To 22.4 liters. So that is equal to 67.2 liters. Already we got the answer. That is 2 moles. Okay, 2 moles of potassium chlorate on decomposition completely releases 67.2 liters of oxygen. So actually the reactions, remembering the equations reactions and their equations are very important. So you have to collect the write the all equations in a single page of different problems. Then so at least daily once or twice you have to read that reactions. Okay. Okay, see the next one. So how many grams? So how many grams of phosphoric acid is needed completely neutralize 120 grams of sodium hydroxide? So here also the reaction is very important. So try to write the reaction. The phosphoric acid H3PO4 with sodium hydroxide. So this is a best reaction of acid and base, acid-base reaction. In any acid-base reaction, we know that the formation of salt and water takes place. Okay, here three hydrogens here. That's why I'm writing 3 H2Os. So I have to put 3 here, and sodium phosphate Na3PO4, sodium phosphate. So 3 sodiums, 1 phosphorus, 7 oxygens, 6 hydrogens. So I have to compare these two only. Okay. So here 1 mole of phosphorus acid is needed to neutralize 3 moles of sodium hydroxide. So in the problem H3PO3 we have to find in terms of grams. So what is the molecular weight of H3PO3? That is 98 grams, just like H2SO4. So 98 grams of H3PO4 need how much sodium hydroxide? We have to find that. Sorry, according to the equation, 98 grams of H3PO3 need 3 moles. It is given in terms of moles, grams. It is equal to 120 grams of sodium hydroxide. So directly answer is there. For 120 grams required how much? 98 grams. So the 98 grams, so 6 hydrogen. So 98 grams of H3PO4 is required. Okay. So the answer is 98 grams. 98 grams phosphoric acid is required to neutralize 3 moles, nothing but 120 grams of caustic soda, that is sodium hydroxide. See the question number 22 in the worksheet. So how many molecules? So here the total different in this problem, that is generally in problems the question will be in liters or grams or in terms of moles, but it is given in terms of molecules. So we know the relation of 1 mole and molecules. 1 mole equal Avogadro number of molecules. We do that calculation here of acetylene. What is the formula of acetylene? C2H2 would be formed when 10 grams of calcium carbide reacts with water. Means we have to know the reaction of calcium carbide. This is calcium carbide with water forming acetylene. Acetylene means that is C2H2, and the byproduct here is calcium hydroxide. So the balancing important, I think already it's balanced. 2 carbons, 2 hydrogens, 2 hydro. So here 4 hydrogens are there, make it 4. 2 oxygens, so it is balanced. So I have to find the number of molecules of acetylene. Acetyl we have to find. So one formed 10 grams of CaC2. Now means the problem is between calcium carbide and acetylene. So first write balanced equation and the number in terms of moles which is given, which we have to find. So 1 mole of calcium carbide with water, it forms how many moles? 1 mole of acetylene. So they are in a 1:1 ratio. But calcium carbide is given in terms, we have to find the number of acetyl molecules, and we have to take the calcium carbide in terms of grams. So convert this 1 mole in terms of grams. So calcium 40, and this is 2 carbons, 40, 24 means 64 grams. 64 grams of calcium carbide produce how much acetylene? 1 mole. So after the moles we convert it into molecules. Okay. So 1 mole. So okay, now only we do it. So 1 mole means how many molecules? 6.022 into 10 power 23 acetylene molecules. So this is Avogadro number. 1 mole equal, it's Avogadro number, simple. Then what about 10 grams? 10 grams of calcium carbide produce how many acetylene molecules? So here also knowing the reaction is a very important one. So on cross multiplication, so on this calculation we will get 6.24 by 64. So on this calculation we will get 0.094. Okay. So 0.094. So already we got 10. 24 by 64. So here we get so 94 into 10 power 1. So that is equal to 940. Okay. So how many molecules are formed means 940 molecules are formed. Okay. So see the next one. So I have to find the number of moles of lead nitrate which are required to be decomposed to produce 48 grams of oxygen. So here the decomposition. So decomposition of lead nitrate is very important reaction. So this is a lead nitrate formula. Okay, lead nitrate on decomposition it forms a lead monoxide and here important nitrogen dioxide and releasing oxygen gas. So 6 oxygens are there for 2 nitrogens. So try to do the 2 nitrogens. So 4, 5, 6, 7. There are only 6 oxygens are there. So to make it 4. 2 to 4 nitrogens. So 2 lead. So 6, 12 oxygens. Careful, 8, 9, 10, 11, 12 oxygens. So this is the balanced equation for lead nitrate decomposition. So here we have to compare the lead nitrate and oxygen. So here 2 moles of lead nitrate. 2 moles of lead nitrate forms 1 mole of oxygen. But here lead nitrate given in terms of moles, no problem, but oxygen is given in terms of mass. So we can write a step here that the number of lead nitrate, actually 2 moles of lead nitrate, 2 moles of lead nitrate required to produce 1 mole. It should be in terms of molecular grams, mass. So 32 grams of oxygen. So then what about to get 48 grams of oxygen, how many moles of lead nitrate is required? So it is given in terms of moles. It's very easy one. Means we need 3 moles. 3 moles of lead nitrate is required. So here also remembering this equation is very important. The oxide, the gases formed here is nitrogen dioxide and oxygen. Let's see question number 24. So what is the volume of carbon dioxide liberated at STP 1? 2.12 grams of sodium carbonate is treated with the excess dilute HCl. So the reaction between sodium carbonate with the excess HCl. So here, so main reaction, it releases compulsory carbon dioxide and forms a salt. So as hydrogen is present, it releases H2S compulsory. So balance the equation: two sodiums are there, two chlorines, two hydrogens, three oxygens, everything is balanced. We have to find the volume of carbon dioxide. The given information is about sodium carbonate. Means we have to compare the sodium carbonate. The 1 mole of sodium carbonate, when treated with excess HCl, so it forms how much carbon dioxide? 1 mole of carbon dioxide. 1 mole of carbon dioxide. So in the problem, what are the terms given? So CO2 given in terms of volume, it is given in terms of mass. So convert them into their respective terms. 106 grams, its molecular weight 106. 106 grams of sodium carbonate when treated with the excess of dilute HCl liberates how much? 1 mole. It is must be in terms of volume. So 22.4 liters of oxygen. Then what about 2.12 grams? So 2.12 grams of sodium carbonate liberates how much oxygen? So on this calculation, make it 212. 6. So that becomes 44.8 into 10 power. Sorry. Means 0.448 grams. 0.448 grams of 0.448 liters. So it is asking about the volume of carbon dioxide. So here 0.448 liters of carbon dioxide is released and 2.12 grams of sodium carbonate is treated with the excess dilute HCl. So here see the question. So when 10 milliliter of H2 hydrogen, 12.5 milliliter of chlorine are allowed to react. So the final mixture contains under the same condition or what? Means we have to write the reaction. It's a very simple reaction. H2 gas, Cl2 gas, all are in gaseous terms. So forms 2 HCl. So actually if you see the ball, it is balanced. They are in 1:1 ratio actually. So 1 mole of H2 reacts with 1 mole of Cl2 forming 2 moles of HCl. So here the information is given for 2 components. So already we know, I think already you got the point that it is a limiting reagent problem. If the information of a 2 compound, the information of 2 reactants given, so we have to choose any one of them. We have to choose only one of them. So that will be known as limiting reagent. So to which we have to select, so which is completely undergoes in the reaction. So now compare the given values. Actually I can do this, both are in 1:1 ratio. But here hydrogen is given just 10 milliliters. So it is given 12.5 milliliters. 10 milliliters react with the 1:1 ratio. Volume is directly proportional to number of moles. So 10 milliliters reacts with 10 milliliter. Remaining 2.5 of chlorine does not undergoes reaction. Means here we can write the limiting reagent directly, that is 10 milliliter of H2. H2 is the limiting reagent. అంటే మనం ఇక్కడ ఫైండ్ అవుట్ చేయాల్సిన HCl దేని బేస్ చేసుకొని ఫైండ్ అవుట్ చేయాలంటే H2 బేస్ చేసుకొని ఫైండ్ అవుట్ చేయాలి. ఒక H2 టోటల్ రియాక్ట్ అవుతుంది 10 mlకి 10 ml రియాక్ట్ అవుతుంది. సో ఇక్కడ ఎక్స్ట్రా 12.5 ml క్లోరిన్లో ఓన్లీ 10 ml రియాక్ట్ అవుతుంది, మిగతా రిమైనింగ్ 2.5 milliliter does not undergoes reaction. Mean it is in excess amount, it is totally completed, consumed in the reaction. So this will be treated as limiting reagent in this problem. So then you consider this a 12.5 ml react అవ్వాలంటే ఇక 12.5 milliliter of H2 ఉండాలి, but 12.5 ml is not present, only 10 ml is present. So here we can write 10 ml of H2 reacts with 10 milliliter of Cl2 only. So means 12.5 minus 10 milliliters. So 2.5 milliliter of chlorine is remain as unreacted. So therefore we have to take this is as a limiting reagent. Therefore H2 is the limiting reagent. With the help of H2 we have to do the problem. Okay. So according to this equation 32.4, actually it is in terms of milliliter, so 22,400 milliliter of H2 produce 2 moles, 2 into 22,400 milliliter of HCl. Then what about 10 milliliter? 10 milliliter of hydrogen produce how much HCl? Just 20 milliliter of HCl. Means so after the completion of the reaction we get 20 milliliter of HCl is there, and also what is unreacted part? 2.5 milliliter. 2.5 milliliter of chlorine is present, and also 20 milliliter of HCl is present in the reaction mixture. Okay. The question number 26, part 5, the volume of hydrogen so required at STP for the complete hydrogenation of 13 grams of acetylene. Acetylene means we know that formula C2H2. Actually here also reaction is very important. Actually C2H2. So acetylene is an unsaturated compound which is having a triple bonds between the two carbon atoms. So C2H2 actually the C2H2, the bonds in it is H bond C, triple bond CH. So it is given that complete hydrogenation. So the complete hydrogenation means so the maximum number of hydrogen can be added to acetylene. That is called complete hydrogenation. So I should get triple bond. So the carbon is having 2 pi bonds. So 2 pi bonds means it can combine with 2 hydrogen, 2 H2s. Totally it combined with the 4 hydrogen atoms. Now it becomes C2H6. C2H6. So make this unsaturated becomes total saturated. So more number of 4 hydrogens cannot be possible. The maximum carbon kunde bond 4 e kabatti. So only 1 hydrogen undi, deeniki 2 hydrogen, deeniki 2 hydrogen. Total 2 H2 molecules and 4 hydrogen atoms can be added. This is called complete hydrogenation. So the common reaction written as C2H2, 2H2 gives C2H6. So It's called ethane. So this is the reaction. So what we have to find? The volume of hydrogen. Volume of hydrogen required for the complete hydrogenation of 39 grams. So I can the equation 1 mole of acetylene, 1 mole of acetylene required 2 moles of hydrogen. 2 moles of hydrogen. So convert it into required times. Acetylene must be in terms of grams. Okay, 30, this is 24, 26. Okay, 26 grams required. 26 grams of acetylene require 2 moles. It's in terms of volumes and rate. 2 into 22.4 liters of hydrogen for complete hydrogenation. But it is given how many grams? 39 grams. 39 grams of acetylene required how much hydrogen? 6. So for the overall calculation, 67.2 liters of hydrogen is required. Let's see the next one. So we have to find the volume of carbon dioxide obtained on complete decomposition of 1 mole of sodium hydrogen carbonate at STP. Sodium hydrogen carbonate is also known as sodium bicarbonate. We have to know it's a decomposition reaction. This is a very important and very common reaction. So sodium hydrogen carbonate forms sodium carbonate, carbon dioxide and water. Okay, so compare the sodium hydrogen carbonate and CO2. So I can the standard equation: 2 moles of sodium hydrogen carbonate releases 1 mole of carbon dioxide. So it must be in terms of moles, no problem, but it should be in terms of volume of CO2. So therefore 2 moles. So for 1 mole, I can do the equation: 2 moles of NaHCO3 release how much? That is 22.4 liter of CO2. Then what about 1 mole? So it's a very direct question, but we have to know the reaction. 1 mole requires how much? Exactly half. It releases 11.2 liters of CO2 will be released. Simple. 2 moles, 1 moles. 1 mole means half mole. Half mole means 22.4 by 2, that is 11.2 liters. Okay, see, step 28. So I'll find the maximum amount of barium sulfate precipitated on mixing of 20 milliliter 0.5 m barium chloride and 20 milliliter of 0.1 m H2SO4 is. So first write the reaction. So barium chloride reacts with the sulfuric acid. We can guess the reaction very easily. So barium combined with the sulfate. So actually the former barium sulfate is in solid state. So totally it occupies the bottom position of the vessel or test tube. That's why we said it as a precipitate. It is in the form of solid, comes to the bottom in the vessel. So the downwards arrow mark indicates the precipitation. And there is a formation of 2HCl. So we have to find the amount of barium sulfate and mixing of 20 milliliter of 0.5 m, 20 milliliter of 0.1 m. So according to the reaction, it is 1 mole and 1 mole, but it is given not exactly moles, it is given in terms of volume and molarity. So means you have to compare millimoles, okay? Because it is given volume, so direct గా మనకి మోల్స్ ఇస్తే మోల్స్ కంపేర్ చేస్తున్నాం. ఇక్కడ ఇచ్చి మనకి వాల్యూమ్ ఇచ్చిండు, మొలారిటీ ఇచ్చిండు, అంటే మనం మిల్లీ మోల్స్ ఈక్వలైజ్ చేయాలి. ఓకే, సో హియర్ హౌ మెనీ millimoles have? So 20 into 0.5, that is a 10 millimoles of barium chloride is given. What about H2SO4? 20 into, that is 0.1 m, that is just 2 millimoles. 2 millimoles of H2SO4 given. So here the information is given for two compounds, but we have to take any one of them. If two informations are given, we have to find out limiting reagent. So with the help of that limiting reagent only we proceed the problem. Okay, what is the limiting reagent? So which is consumed totally in the reaction. Means here they are in 1:1 ratio. So moles nothing but millimoles, volumes are exactly equal at STP. Okay, if no conditions are given, we have to consider as STP. So 2 millimoles react with the 2 millimoles of barium chloride. So remaining 8 millimoles of barium chloride are unreacted. Means what is the limiting reagent which is given in less when compared to this? Here 1:1, 10:10 not possible because there is no only 2 millimoles are there. So then we have to consider 2:2. Remaining 8 millimoles are unreacted of barium chloride. So here limiting reagent is H2SO4. Means we have to proceed the problem. So by taking H2SO4 millimoles. Okay. Means we have to proceed the problem by taking H2SO4. We have to find barium sulfate. Here what is the ratio again? To 1 mole of H2SO4, 1 mole of barium sulfate. It is in terms of millimoles. So here we can write 1 mole of H2SO4 can form 1 mole. So 1 mole of barium sulfate. Precipitation generally we written the shortcut PPT. So here it is in terms of 1:1 ratio. So 2 millimoles of H2SO4 also forms how much? So very simple, 1:1 ratio means 2 millimoles also produce 2 millimoles. Is also produce 2 millimoles of so therefore answer is 2 millimoles of barium sulfate is precipitated. I think option is given in terms of moles. So millimoles means 2 into 10 power minus 3 moles. So moles of barium sulfate. So see the last one. So to find the percent loss, we have to find the loss in the weight after heating a pure sample of KClO3. This potassium chloride, we know the decomposition of potassium chloride. So the KCl and O2. So we have to find the what is the loss in weight. So actually there is no loss in the weight during a reaction according to law of conservation of mass. So why it is given means so actually the potassium chloride is solid. So this is in terms of gas. Means whatever the product formed, some of the product is evaporating. Means some of the product is escaped from the vessel. So means we have to find out how much oxygen is went out. Okay, means the loss in the weight means nothing but the weight of oxygen formed. That is simply given indirectly. So what is the potassium chlorate, and we have to compare it with the oxygen. So here two, what is this molecular weight? So in terms of weight, 2 moles means what is molecular weight? Is 39, 35.5 is 48, approximately, sorry, I get exactly 122.5, that is 245 245 grams of potassium chlorate releases. So here it is important one. You can do in terms of KCl, or you can do in terms of O2 also. So O2 means directly we get the loss. Okay. So release. How many grams of O2? 3 into 32 grams of oxygen. So why you are calculating oxygen means whatever the loss is obtained in that vessel, that is equal to the mass of oxygen. So 245 grams releases 3 into 32, that is 96 grams. So 96, so therefore what is the loss? Therefore 96 grams. Therefore 96 grams of loss in weight is observed. So what is the percentage? Actually we have to find the problem in terms of percentage. So therefore percentage loss equal to the 96 grams is loss in how much? 245. So here we get so that is loss percentage is 39.18 percentage. Okay. So these are the different questions. So I think all we done maximum question. This very only 1 or 2 questions are there. You have to try that questions. Even you do if you are not getting that answers, just ask me. Okay.